So now that we know how to solve a polynomial and describe a polynomial, we want to put it all together and end up graphing a polynomial. Okay, so the first thing that we would do is we're going to go through and we're going to solve the polynomial, like what we had just talked about. Once we get those solutions, we're going to put those values on an x-axis. Now, when we talk about solving a polynomial in this course, all we want to do is look at it kind of on a number line as the x-axis. So we're not going to be too concerned with any y values or actually graphing it on an xy coordinate. We're going to be looking at it more of a rough sketch when we talk about polynomials. Okay, so we're going to put those x values on an x-axis acting like a number line. Then we're going to draw our end behavior. Remember, our end behavior comes from that leading coefficient test, so we're going to have to describe that polynomial a little bit. Then, using the idea of our multiplicities, we're going to have to connect the end behavior and each of those x-intercepts together to eventually create our actual graph. Okay, so let's look at a couple examples of this. So let's say for our first example, we're going to start off nice and easy. It'll already be in factored form. Let's say that we have f of x is equal to a negative 5x squared times x minus 1. Then let's say we have 3x plus 2 and x minus 4. All right, so let's say that this was our factored polynomial. So the first thing that we would want to do is we want to solve this polynomial. So to do that, since it's already in factored form, I'm going to set each factor equal to 0 and solve it. So I'm going to get negative 5x squared equals 0, x minus 1 equals 0, 3x plus 2 equals 0, and x minus 4 equals 0. So solving each of those, I'm going to get x is equal to 0, x is equal to 1, x is equal to negative 2/3, and x is equal to 4. Now remember about our multiplicities. This x is squared, which means this x equals 0 is going to have a multiplicity of 2, which means it's going to be on there twice. Okay, so now that we have solved our polynomial, we want to remember what the end behavior would be. So for the end behavior, we need the a and we need the n. Remember, the a is going to be the number in the very front, so it's going to be our negative 5, which means that it is indeed negative. Remember, for the a, I'm looking, is it positive or negative? Now, for the exponents, I'm going to need to add them up. So there's 2 here, 1 here, 1 here, 1 here. So that's going to give me n being 5 as I add up 2 plus 1 plus 1 plus 1. So now that it's 5, I can see that that's an odd number. So the end behavior says if it's negative and odd, it's going to go from the top to the bottom. And I don't have to give a full explanation saying that it's going to rise to the left and fall to the right. That's not what I'm looking at. What I'm really looking for here is to know what the arrows are doing so that I can connect it here in just a minute. Okay, so now that we know all of these things, we want to go start trying to create this graph. So I'm going to get this x-axis number line on here. And it doesn't have to be perfect, but I know my smallest number is negative 2/3 and my largest number is 4. So I'm going to actually go from negative 1, 0, 1, 2, 3, and 4. All right. If the numbers are really far apart, I don't really need to have an exact number line. I can make some jumps in between. All right. So now that I've got my number line going here, I'm going to go ahead and put these values. I'm going to put 0 as a point. I'm going to put 1 as a point. Negative 2/3 is going to be somewhere around there. And then I'm going to put 4. So I've got my I've got my 4 x values, or x-intercepts on my graph. Now I'm going to draw my end behavior. So I'm going to go to the end points. So if I go to the left end, the leftmost point here, it's going to connect to the end behavior of going up. And then my rightmost point is going to connect to the end behavior of going down. And it doesn't matter exactly how if I want to draw a straight line or if I want to curve it a little bit, right? Remember the idea is here in a minute, it's going to be smooth and continuous. All right. Now, the last thing before I start connecting and making this smooth polynomial, I have to go back and remember about the multiplicity and how many turns that I might have. So remember, if the highest exponent was 5 here, right, my n was 5, that means that I had 5 solutions, but I'm also going to have 4 possible turns. All right, so when I looked at these 5 solutions, one of them was actually repeated. Okay, so that multiplicity is going to do something different when I actually get on that x-axis. So that's what we talked about up here. An even multiplicity, which this is even because the number 2 is even. So an even multiplicity is going to actually sit on the x-axis and turn back around. What that means is this is going to become a turning point. Okay, it's going to count as one of my turning points as well as an x-intercept. If it was an odd multiplicity, which all these others are odd because this is a 1, this is a 1, this is a 1, it's going to cross through the x-axis. All right, so I'm going to connect these end behaviors using my multiplicities on these x-intercepts. So at -2/3, it should cross through because it's only on there one time. So I'm going to cross through the axis, and then I'm going to have to turn back around. So at some point down there, I don't know where it is, and I'm not too concerned about it right now. Remember, all we care about is our x-axis here. So if your turn is a little bit lower or a little bit higher, it's okay, as long as it doesn't cross back through the axis. Okay, so now when I get to 0, I come over here. 0 has an even multiplicity, so it's going to sit on the axis. So I cannot cross through. I'm going to have to sit, and I'm going to have to turn back around. So notice now that x value becomes a turning point. All right, so I'll go down a little bit further. Doesn't have to be any different here. That could be the same as last time. And I come up here to 1, and then I have to ask myself, well, what am I going to do? 1 is on there one time, so it's going to cross again. So I'm going to cross through the x-axis here. Okay, now eventually I'm going to have to turn back around so that I can make it to my number 4 here. Doesn't matter really where it happens, just that it happens. And I get to 4, and 4 was only on there one time, so it should cross again, which it does to connect with that end behavior. So now I would have a sketch of this polynomial function. And if yours looks a little bit different, that's fine. Some of you may have drawn it a little bit differently. So I could have done the same thing. I'll show you in this red here. I could have had something like this, right? It could be nice and small, however you want to kind of look at it. But in the end, what we're looking for is, do the ends do what they're supposed to? Do I sit or cross at the correct spot on the x-axis? And do I have those 4 turns? So 1 turn, 2 turns, 3 turns, 4 turns, right? So that's what we're looking for when we graph it. All right, so let's look at another one and kind of go through all of the steps, maybe something that's not in factored form here. So let's look at one more of the graphs. Okay. So let's say we have f of x equals 2x to the 4th minus 3x cubed minus 12x squared plus 7x plus 6, right? So this time it is not factored. So what that means is, instead of setting each factor equal to 0, I need to go through and I need to make my list using my rational root theorem. So I'm going to make my list, numbers that multiply to 6, numbers that multiply to 2. So my list is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, right? All those numbers multiply to equal 6. Then I'm going to have numbers that multiply to 2, so plus or minus 1, plus or minus 2. So now let's get my actual list. I'm going to take them all, and I'm going to divide, and I'm going to get 1, 1/2, 2. 2 over 2, it's already on there. So then I'm going to get 3, 3 over 2, 6, 6 over 2, which is 3, is already on there. So this list is what I'm going to try to find for my solutions. So let's go do this. Now again, I already know what some of the solutions are. So I'm going to go ahead and show you just a few of those. So let's say that we started off and we thought that one of our solutions, or we just start going through the list and we go and we evaluate it, -2. So when I plug in a -2 into my equation, I'm going to end up seeing that that my remainder with the x value of 2 is going to equal 0. So that indeed would be a solution. So actually, when I go through, I'm going to try each of these, and you can try them and see that they would work. I'm going to get 0 when I plug in a -1/2. I'm going to get 0 when I plug in a 1, and I'm going to get 0 when I plug in a 3. So all of these would be my solutions to my polynomial. All right, so x is going to equal, and I'm going to write them in number order so it's going to be easier when I go graph. So x would equal -2, -1/2, 1, and 3. So now the idea is we're going to go graph these. So to graph them, I need to make sure that I know what that end behavior is. So my end behavior, I need to take my a and my n. So since it is in standard form, I'm going to take my highest exponent, which is 4, to be my n, my leading coefficient, which is 2. So I've got a positive even, which means my end behavior is going to be up, up. Okay, so let's put my x values on here. So I'm going to start at -2, -1, 0, 1, 2, and 3. I'm going to go put the point -2 on there. I'm going to put the point -1/2 on there. I'm going to put the point 1 and the point 3. I'm going to connect that with my end behavior. The end points are both going up. Now, none of these have a multiplicity that is even. So what that means is each of these are going to cross through the axis. So I'm going to cross through, turn to come back up and cross, turn to go back and cross, turn to go back. And I can see that I have 1, 2, 3 turns. If my highest exponent was a 4, I should have 3 possible turns, and I do. Okay? So that would be how I would graph if I was in standard form versus a factored form. The idea is that I'm going to solve. However I do that, I'm going to solve. I'm going to get my solutions. I'm going to put them on a number line, connect them with the end behavior. So I need to find that end behavior. And then checking with the multiplicities, I'm going to connect the points with a smooth curve, deciding if I'm going to cross or sit on the axis.